Hi. So for number 86, we have two things to prove. We have to show that we have x-axis symmetry. And to show that, what I need to do is substitute in the positive r for r and negative theta for theta and show that I really get the exact same thing. And then for 120 point degree symmetry, I'm going to substitute in r comma 120 degrees plus theta, and again show that I get the exact same thing. So let's start with the x-axis symmetry. Make some more space here. So in place of r, I have an r, then I have 7 cosine 3 times negative theta. And if you remember from last semester, we had these odd-even identities. And one of them was for cosine of negative theta, which is equal to just cosine theta. So if I apply that identity here, I get cosine 3 theta, and because this is exactly what we started with, I'm done with that. Next is I need to do the 120 degree point symmetry about the origin. So again, with r, I'm going to replace r. And then where I had theta, I'm going to plug in 120 degrees plus theta. So when I distribute the 3 through, I get 360 plus theta. And then the angle sum and difference formula for cosine. That says cosine of alpha plus beta is equal to, oops, it was a plus or minus there, cosine alpha, cosine beta, shoot, is it plus or plus minus? Or I looked it up and it's minus plus, not that it really matters here, sine alpha, sine beta. So that's what I'm going to use now. So it's r 7 cosine 360 times cosine, oops, that's a 3 theta, forgot to distribute the 3 to the theta there, 3 theta minus sine 360 times sine 3 theta. And if you recall, the sine of 360 is 0. So that last piece just kind of drops off. And the cosine of 360 is 1. So I'm left with 7 cosine 3 theta. And because this is exactly the same as that, we are finished. So that's what we do for 86. So for 96, the first thing I'm going to do is try to determine the type. So if I have a rose curve, this would look like r equals a times cosine of n theta, or r equals a sine n theta, which is not what we have, because we have this extra 8 that's being added to the front of it. If I have a limacon curve, the form of those is a plus or minus cosine of theta, a plus or minus b cosine theta, or r equals a plus or minus b sine theta. So if I look at this, it's pretty clear that this is a limmason, is my type, and a is equal to 8, and b is equal to 10. So remember on the limmason, the a's and b's are always positive values. And then I'm just going to use the information that I know about limmason curves, because I know that this is limmason. So, for example, if I want the maximum r value, I know that this is equal to, or r is equal to, a plus b. So in that case, we're 18. If I want the number of petals, we know that the number of petals is not applicable because we're not talking about a rose curve. Silly me. Right? That's a rose curve description. Remember, the limmason curves are either the inner loop, the cardioid, the dimpled limacon, or the limmason, and then the convex. So we can say what type this is, and the way we can tell that is just comparing a over b. And since a over b is, so a over b is 8 over 10, and since that's less than 1, this is an inner loop limmason. So we can say that. What else did it ask for in this question? Domain and range. Okay. So the domain is always going to be all real numbers. And then the range is always going to be a minus b, comma, a plus b. So in this case, that means that we have -2 to positive 18. And because of the last thing is talking about the symmetries, and the way that this works is the cosine limmasons are symmetric about the x-axis, and the sine limmasons are symmetric about the y. So we have also x-axis symmetry. Oops, so there was my domain and range. So that, I think, is all the details that you would want to include for a limmason. I don't think there's anything else. Again, if you were, some of these facts that I just wrote down, these were all things that we did in the notes. So if you go back and you look at the 10.5 notes, you know, like we have all these facts for the rose curve, or all these facts for the limmason curve, and this is just kind of what I'm using there to do those problems. I hope that helps, and good luck.